If you assume any rate of advancement in AI, we will be left behind by a lot.
That is Elon Musk, the inventor and entrepreneur behind such futuristic endeavors as Tesla, SpaceX, and Hyperloop. And as you heard, Elon Musk has AI, artificial intelligence, on his mind these days. He says AI machines could soon outsmart us all. And his philosophy is if we can't beat them, we should join them by implanting AI computers directly into our brains.
One of the solutions is to have an AI layer. If you think of like you've got your limbic system, your cortex, and then digital layer, sort of a third layer above the cortex that could work well and symbiotically with you.
Of course, turning humans into cyborgs may sound like the stuff of science fiction, but then again, that is Elon Musk's forte. So would he develop this kind of technology himself?
Somebody's got to do it. I'm not saying that I will, but somebody's got to do it. Somebody should do it. And I mean, if somebody doesn't do it, then I think I should probably do it.
Well, it appears he has. Later this week, Elon Musk will be letting the world in on his latest venture. We do know that it's called Neuralink. And for more, we are joined by science journalist and futurist George Dvorsky, who has been covering this for Gizmodo. George Dvorsky is in Oakville, Ontario. Hello.
Hello. Thanks for having me this morning.
So what are you expecting Elon Musk to announce later this week?
Well, I certainly expect some more details. Right now, the so-called Neuralink is quite vague in terms of what this is supposed to look like, what it's even supposed to do. Aside, of course, from some of the comments that Musk has made in recent months. Specifically, though, what I am expecting to hear, though, will be, I guess, the initial approach towards achieving this. These chips that will be implanted in our brain and what we hope to accomplish with them. Initially, it's quite conceivable that Neuralink will be working not to enhance or to even add AI to our brains initially, but to actually become therapeutic. These same technologies can be used to treat, say, Alzheimer's or Parkinson's or even seizures, for example. And I think that's a good pathway into this particular area. But knowing Musk, of course, and knowing the kinds of visions that he has, he's not going to be content to stop there. And with the same sorts of technologies, you can now start to perhaps modify other aspects of cognition, things like memory and intelligence, even, for example, transmitting thoughts to and from a computer. Just with just thinking about it, you could transmit your memories and your thoughts to a computer. It's difficult to say if Musk will get to that level of specificity in his comments later this week, but that's certainly what I'll be looking out for this week.
Well, George, that his venture is to develop something called Neuralace. Can you help us picture what that is?
Because he used the word lace there, I'm imagining that it is going to be a kind of mesh that will be overlaid over certain parts of the brain. As we know, the brain isn't just this big piece of mush that does everything and anything everywhere. Our brains are broken down into different modules. So, for example, if you put this mesh area around the motor cortex, the area that controls movement, then this lace would pick up those signals. When we say, for example, I want to move my finger or I'd like to move my leg, the lace will pick up those signals and it will then transmit those signals, I would hope wirelessly, because no one wants to have wires sticking out of their heads. And we already do have chips in animal models, for example, that can transmit wireless signals to a receiving device, namely a computer. Hence, which is why we're using the word interface here. So it basically would look like that, kind of a mesh. If not a mesh, or the lace could also conceivably be a literal chip, a literal brain chip that rests at a specific area of the brain.
Well, we're talking about something surgically implanted, though, eventually.
Absolutely. In order to get the kind of fidelity, the kind of the power of the signals to move, let's say, an artificial arm or to even transmit our thoughts, we're going to have to get right there into the brain. I mean, we do have what are called EEG technologies today, which is like a cap you can wear on your head. But the amount of information that can be extracted just through your electrical signals externally is extremely minimal. You might be able to make a gesture like you're thinking of moving to the left or you're thinking of moving to the right. But no, if you want to get down to the levels that Musk is talking about, we've got to get right into the brain itself.
Well, we've got somebody waiting in the wings who's already using technology where the brain can control a limb through, or the brain can control movement of a machine. So what would be different with this technology? What would he really want to use it for?
Well, I mean, he wants to save the world, apparently. And I mean, right now, as I mentioned earlier, there's going to be a therapeutic aspect to it. That's going to be wonderful. And he has listed this company it is listed as a medical firm. So they are going to be producing medical devices at first. And of course, this is a multi-million-dollar industry. So he knows what he's doing by, becoming one of the first to market here. But as Musk has said, artificial intelligence is progressing rapidly, and we're getting to the day, maybe 20 years from now, maybe 50 years from now, but we will get there eventually when artificial intelligence exceeds human capacities in virtually every way. And Musk's solution is an interesting one. He's not the first to suggest this. Other futurists have also suggested this, is that the best way for us to be able to control and contain our artificial intelligence is that if you can't beat them, join them mentality, and we will merge with our machines. So the idea here that he literally believes that we can kind of save ourselves from perhaps subjugation or some kind of an artificial intelligence disaster by augmenting ourselves along with our artificial intelligence. And that way we can kind of keep up with them should anything go askew in the future.
Do you see any resistance to this as he goes forward?
Most certainly. I mean, as I'm sure that your listeners are aware, that this issue is fraught with ethical difficulties. Everything from how do you find test subjects who are willing to have chips implanted into their brain or these meshes implanted into their brain? What kind of levels of consent can you get? I mean, at this point, are humans being treated as a means to an end in order to, let's say, stave off the threats posed by artificial intelligence? What kind of animal testing would be required, through these kinds of experiments? And of course, there's the broader, more philosophical question as to what this means to our humanity. What does it mean to us as humans? For example, these sorts of technologies don't just stand to improve our intelligence to, let's say, Einsteinian levels, where we are these mathematical, logical geniuses. These technologies, they have the potential to utterly transform what we are as humans and enter into the realm of the so-called post-human. In other words, this kind of entity that exists after humans. And at this point, I mean, we're talking thousands, if not even millions of times, greater levels of capacity than current humans. So we have to ask ourselves right now, how will these technologies alter who we are as humans? In what ways could that be of benefit? In what ways could that be detrimental? So it opens up a whole area of discussion for sure.
Well, we'll keep the discussion going. George Dvorsky, thanks for your thoughts.
My pleasure.
George Dvorsky, science journalist and futurist. He's in Oakville, Ontario. Brain-to-brain or brain-to-machine interaction may be Elon Musk's latest passion project, but my next guest has been doing pioneering work in that field for decades. Miguel Nicolelis is a professor of neuroscience at Duke University. He also runs a lab in Sao Paulo, Brazil, and that's where we've reached him today. Hello.
Oh, hi. Good morning.
Good morning. How soon do you think we'll be connecting our brains to computers?
Well, we have been connecting our brains to computer for a while, since the late 90s at least. But what I have heard so far, either in the announcement and the commentary that we just heard, is really far removed from reality and far removed from what we consider as a scientific field. Of brain-machine interface is the name of this field. Basically, we cannot download our thoughts or upload, all the works of Einstein in our brains and suddenly become theoretical physicists that can win a Nobel Prize. This doesn't exist and probably will never exist. Neither should we be worrying about the possibility that artificial intelligence, which is all totally based on digital logic, may one day overcome the human condition. That is also preposterous because we don't work based on digital logic. And we simply cannot be threatened by machines that never, ever will acquire the notion of what is to generate knowledge or to process information the way we do. So these are all scenarios that sound beyond science fiction. It sounds pretty preposterous to me.
And tell us what you're doing, though, because you're working with monkeys, and they are actually able to move things. What does your work do?
Yeah, we have been working with monkeys and humans for a while now, and we can, exactly using brain-machine interfaces, we can record motor intentions and allow subjects, animals or humans, to control the movements of robotic arms, robotic legs, even virtual bodies through these brain-machine interfaces. But we are talking about movements and simple movements. We are not talking about as I said, downloading our memories, which can not be done because these memories are embedded in the tissue of the brain and cannot be extracted by any recording device that we have so far. And I don't believe we will have anything that can do that.
So
but
the application of what you're doing is for people with this would be reparative, right? This would be about people who are quadriplegics, paraplegics, who can suddenly move limbs. That am I right?
Yes, exactly. We have developed, first of all, in the 90s, we developed brain-machine interfaces to study the brain, to investigate the basic principles of physiological principles of how brains operate. And then we suddenly realized that we could apply this into to rehab patients that have suffered devastating lesions of the central nervous system. And that's exactly what the field has done. Our lab has shown first with upper limbs and now with locomotion that, in fact, you can use EEG in the case of locomotion to get paraplegic patients to control exoskeletons and to walk. And this effort, the most important aspect of this effort has been that you can induce partial neurological recovery in these paraplegic patients by letting them use these brain-machine interfaces in a routine kind of training. So exactly everything that is working really in this field is geared towards medical applications. And the fact that someone is considering the hypothesis of implanting healthy human beings crosses a variety of ethical boundaries that I think will never be accepted by any board anywhere in the world.
Well, okay, so let me ask you just a few more questions in the limited time we have. So the machines you're working with now, brain signals are sent to machines to move them, to move the limbs then.
Yes.
What about the reverse? Can machines feed information directly into our brains?
Well, in animals, we have shown that you can send signals back to from a robotic or a virtual arm back to the brain, but this is a very limited kind of information that you can send. We are just learning how that can be done. We also have shown that you can exchange information and you can combine information from multiple brains to achieve a particular task. We call that a brain net. But again, the amount of information, the quality and range that you can send back to the user of a brain-machine interface system is very limited and is nothing close to uploading a thought, uploading a language, or any kind of knowledge. That doesn't exist.
Are you at all worried, though, about the unintended consequences of that technology?
Oh, I'm very worried. I'm worried about this type of announcements that seem to be just self-promoting marketing tools and to take us a field that is very serious, and it has put a lot of effort to propose things that are not even science fiction. They're bad. They're really not well thought. And this mesh that Mr. Musk has been talking about has been tried once in a mouse preparation, and it is several decades from being used in humans. So it's very concerning. It's very worrisome.
And so are you, but given how much you have advanced with your research, is it totally off the charts to say that the research could get to the point in the future where the kinds of scenarios he's talking about could exist with our brains?
Well, the scenarios of rehabilitation, of course, they will come, and they're already here, and we will see more of it. I have no doubt about it. The field is progressing very nicely and will help millions of people in the future, I have no doubt. Talking about augmentation of healthy human beings, a lot of what I heard, both from an announcement and from what the media has talked about, is not real. It's not going to happen. Besides, the rationale for suggesting the creation of this company is bogus, is baloney. Machines are not going to supplant human beings. This is a kind of hype that has been going on for a few years. That looked funny in the beginning, but now it's starting to look pretty dangerous to the point of suggesting experiments in healthy human beings that are basically unethical.
Miguel Nicolelis, thanks for your time today.
Thank you. It was a pleasure.
Miguel Nicolelis, professor of neuroscience at Duke University. We reached him in Sao Paulo, Brazil, where he runs a lab on this very issue. Well, when you start down the path of boosting brain power through artificial intelligence, or even just musing about it, you arrive at hefty ethical considerations. James Giordano is a professor in the Department of Neurology and Biochemistry. He's chief of the Neuroethics Studies program at Georgetown University Medical Center. He's in Washington, D.C. Hello.
Hi, Anna Maria. How are you this morning?
Well, I'm curious to know what you're thinking. What are the ethical implications of this technology? First, when it comes to safety.
Well, I think Mr. Dvorsky has raised an interesting question. Is this safe? And clearly, there have been ongoing studies looking at brain-machine interfaces and brain implants, and it is a neurosurgical procedure. So I think all of the necessary safeguards that go into neurosurgery are necessary. But that brings us to the next point, which is, who are we doing this in? Are we doing this with people who have a pathological condition, for example, a neurological degenerative disorder or brain trauma that would necessitate the implant? And the answer there is no. So we have to balance safety with need.
But how would that be ethically different from other surgery?
Well, in many ways, it isn't. I mean, the idea of neurosurgery carries with it its own ethical burdens, of course, all the necessities that would go into any medical consideration. But as Mr. Dvorsky has mentioned, and of course, as Professor Nicolelis had mentioned, the intent here is not necessarily, at least completely, for therapeutic benefit. It's towards some form of competition with AI and or some form of human enablement or enhancement. And then you have to really take a look at, is this necessary or not? And I think the jury is still out on that. I tend to side with Professor Nicolelis in saying we really don't see such a threat coming from AI, at least not one that's realistic with regard to being able to threaten or put at risk the human condition.
If we get to the point where this could actually be something, and I'm saying if because Professor Nicolelis has made the point this may just be fantastical, who would even have access to technology like this?
Well, this is a huge question, Anna Maria. I mean, the question here is who's going to get it and who isn't. And in many ways, what you're really seeing is a broadening of the gap between the haves and the have-nots. And this would then be the neurologically enhanced haves versus the non-neurologically enhanced have-nots. So characteristically, you would then say that those individuals who could afford this type of enablement or enhancement would be the ones to get it. Whereas if you're looking at a therapeutic situation, it would be those that may have the greatest need. And of course, here too, you're looking at a variety of issues such as insurance capability, standards of care, et cetera.
You're involved in the adaptation of this technology for the U.S. military. How is it being used?
Well, we're really not looking at implantable technologies as being able to create some capability with AI. What we're looking at here is a capability of implantable technology such as deep brain stimulation, and even the type of thing that Mr. Musk is alluding to, where we have an interface between the superficial levels of the brain and a computer interface or machine interface, mostly to be able to compensate for neurodegenerative diseases, injuries to the brain, etc. Now, that's not to say that this cannot be used to perhaps augment or enable individuals to engage information processing, process information more quickly and more efficiently. But we're really not looking at the implantable technologies to do this as much as the non-invasive brain stimulatory technologies. For that very reason, they're non-invasive. They tend to be far safer with regard to the surgical procedures that aren't needed. And also, I think we're able to modulate the level of the input in different ways without having to worry about using surgery to get these things in and access to the brain.
Do you have concerns about how this could be abused?
Oh, of course. I think as with any type of science and technology, it is highly misusable and in some cases abusable. I mean, obviously, we're also dealing with a technology that is very new. And so we're having to open the door of questions of the unknown. We don't know what this technology is going to be able to do. And in many ways, that's part of the reason that we're going forward with this experimentally, because we're not only learning about the technology, we're learning about the brain. And then in learning about the brain, we're adapting our methods and technological tools. But I think when it's very early in its development, clearly, one of the things we have to look at is, do we really understand the consequences of what we're doing? Do we understand that there may be some unanticipated effects? And are we prepared to consent patients to do that? And if we are prepared, do we also have the continuity of care and research in place so as to be able to take care of these individuals if and when something were to go wrong?
Okay, well, James Giordano, thank you for your thoughts on all of this today.
My pleasure, ma'am. Thank you.
James Giordano is a professor in the Department of Neurology and Biochemistry and chief of the Neuroethics Studies program at Georgetown